Hi and greetings to all. We are from CS Group 6 and are excited to present our comic title The Moon Follow Us.
Our objective is to explain the concept of parallax, which is how objects appear to shift based on our perspective and its connection to trigonometry. This comic aligns with SDG 4, which is quality education by making learning fun and encouraging curiosity about the world around us.
Dad, why is the moon following us?
Son, the moon isn't actually following us.
Huh?
It's called parallax.
What is parallax?
It's when something far away seems to move with you, even though it's not.
The farther something is, the less it shifts. That's why the moon looks like always staying with us.
Oh,
Do you know how we measure the moon's diameter?
with a gigantic ruler.
No, we use mathematics.
But how?
Let's check it out with the telescope.
But first, let's call all the scientists to explain how we measure the moon's diameter.
Now, we measure the diameter of the moon is inside the telescope using a ruler. After that, we find the focal length of the telescope, which is distance between lens and its focus, which is 100 millimeters.
So before we start our calculation, we need to find the angular size of the moon first. Angular size is how big something looks into your eyes, depending on its size and the distance between your eye and the object itself. But instead of using our naked eye to find the angular angle or angular size of the moon, we use the telescope.
Okay, now we would like to find the actual diameter of this moon. First of all, we already get the theta inside the telescope. Now we would like to find the theta for the real life situation. Okay, so as we all know, we already get the theta for the telescope. Now we can use the theta for the real life situation using the same theta. Why? Because we still look at the same moon. So we can still use the same theta to calculate the diameter of the moon. But first thing first, we need to find the distance between moon and earth, which is 384,400 kilometers.
So we need to find the theta for the triangle. As we have the focal length, which is the 1000 millimeter, and the diameter, which is 10 millimeter, and the radius is 10 over 2, which is 5 millimeter. So we use tangent formula, which is tangent theta over 2 equal to the 5 over 1000. So we get degrees, which is the 0.573.
So let's put the angle into the formula, which is tan 0.573 per 2 equals to diameter per 2 divided by 384,400 kilometers, which is the distance between the moon and the earth. Now, the answer is the diameter of the moon is approximately 3,844 kilometers.
I got it. It's 3,844 kilometers something.
Not perfect, but close. Real scientists use precise tools for exact values.
Guys, let's go home. It's late.
Mom, that was so fun.
I'm glad that you like it. Next time, let's measure the distance to a star.
Yay!
Thanks for watching!